Here we are going to see about traveling salesman problem. In this traveling salesman problem, we are going to find the shortest route given to n cities. Visit each cities exactly once before reaching from where it is started. Meaning is எல்லா சிட்டியும் visit பண்ணுவோம். எல்லா சிட்டியும் once, that means we have all the nodes. Each node should be visited once. No node should be revisited, and the starting node should be the ending node. And here the minimal value is calculated, so we are going to find the lower bound. So the lower bound is calculated. So the minimal lower bound is expanded. Lower bound equal to sum of cost of least two adjacent vertices divided by 2. So a node is considered. First we have to see the direct connection of the node with all the nodes. We have to add the minimal lower bound values, that is minimal cost adjacent nodes. 10 நோடு 4 நோடு இருக்குன்னா 4 நோடு ஒரு நோடுக்கு 4 நோடு டைரக்டாக கனெக்ட் ஆகுது. அந்த 4 நோடில் எந்த நோடு 2 நோடுக்கு மினிமல் வெயிட் இருக்கோ அந்த 2 நோடில் மினிமல் வெயிட்டை ஆட் பண்ணி 2ஆல் டிவைட் பண்ண போகிறோம். Next, minimal lower bound is considers the optimal solution. Constraints to be followed. The starting and ending node should be the same. The travel all nodes at least once. The node once visited should not be revisited. And after calculating everything, we have to find the minimal cost of traversal. So each level we will have multiple values. After calculating the multiple values, we have to find the minimal among this calculated lower bound values. Here, the initial lower bound is calculated by finding two minimal edges among nodes. The initial lower bound is considered the root node. Initial lower bound is calculated and that is considered the lower root node. Because after finding the root node only, we will be getting expandable nodes. ரூட் நோடு ஒரே நோடு, அந்த நோடை எக்ஸ்பேண்ட் பண்ணும்போது தான் மல்டிபிள் நோட்ஸ் வரப்போகுது. அந்த நோடில் 5 nodes இருந்தால் 5 nodesல we will be calculating lower bound for all the 5 nodes. After calculating the lower bound for all the 5 nodes, the minimal lower bound will be considered. Here we are going to see 1 minimum distance, 2 minimum distance and 3 minimum distances. 1 minimum distance means A to B or A to C, A to D. This is 1 minimum distance. A to B, B to C, this is 2 minimum distance. A and B one minimum distance, B and C another minimum distance. Another 3 minimum distances, A to B, B to C, C to D. This is 3 minimal distance. A to B, B to C, C to D. That is 3 minimal distance. And we have said that it works so efficiently by faster calculating the lower bound. Here first 1 minimal distance is first made as the one level, 2 minimal distance is considered the next level, 3 minimal distance is considered the next level. This is the example for the traveling salesman problem. In this example, we are going to find the lowest value or lowest minimal bound value. Here the node A, B, C, D, E are nodes, and from these nodes the weight of the node is considered and the lowest value will be considered. 1 plus 3 plus 3 plus 6, 1 plus 2, 3 plus 4, 2 plus 3 divided by 2. Here 1 plus 3 is nothing but each node is considered. This is the minimal value of A node, minimal of B node, minimal of C node, minimal of D node, minimal of E node. That is, A node is considered. A க்கு 8 ஒரு weight, 1 ஒரு weight, 5 ஒரு weight, 3 ஒரு weight. Direct connect ஆயிருக்க node. A க்கு E ஓட direct connection, C ஓட direct connection, E ஓட direct connection, B ஓட direct connection. Minimal value should be considered. Minimal பார்க்கும்போது A to C, 1 will be the minimal. Next minimal is A to B, 3 is the minimal. Next, B node consider பண்ணும்போது B is directly connected to A, C, D and E. The minimal weight is A to B is connected, that has minimal weight of 3, and B to C connected, that has minimal weight of 6, compared with 7 and 9. That is added. Next one is C is connected to A, B, D, E. C is connected to A with weight of 1. C is connected to E, weight of 2. And remaining are non-minimal weights, that is not considered. Next one is D. D to B, D to A, D to C and D to E. In that the weights are D to B is 7 and we have weight 4 and 3. In that minimal weight is 3 and 4 is considered and that is added. Last node is E. E is connected to A, E is connected to B and E is connected to C, E is connected to D. The minimal is 2 and 3 because 8 and 9 are maximal weights. So minimal weight 2 plus 3 is added and the resultant will be 28 by 2, that is 14. As discussed in the previous step, lower bound value of the first step is calculated. When we go for the next step, we will be seeing A comma B in this A to B, A to C, that is calculated. That is direct connection of the node with A is calculated. A is connected to B, A is connected to C. So the minimal value is taken, that is 8, 1 and 3. The minimal value is taken. A to B is 3 and A to C has another minimal value 1, that is 3 plus 1, 4 is taken. When B, next node B is considered, we have the weight 3, 6, 7, 9. In this minimal values 3 and 6 is considered, B2A is 3 is considered and B2C 6 is considered. 9. Next C node is considered. C node has value weights 1, 2, 5, 4. Here 1, 6, 4, 2. Considering these things, we will be having the minimum value is A equal to CS1 and C2 ES2. These two are minimal, so that are concerned, that is added. Consider node E, D, and you have the minimal values for the directly connected. Just this is directly connected, this is directly connected, this node is directly connected, and this node is directly connected. The minimum is 3 and 4, that is added, and the resultant is 7. E node is directly connected to A and B, C and D. So 2 and 3 are the values. 2 plus 3 is added and resultant is 5. Adding 4 plus 9 plus 3 plus 7 plus 5 gives us 28. 28 divided by 2 is 14. This is considers the next. Here we have calculated the values of A to B. And A to C is calculated, A to D, A to E are calculated. A to C is not given because B is not before C, so it is not calculated. And A to D is calculated, A to E is calculated. After calculating A to B, A to D and A to E, lower bound is verified. Lower bound of A to B is 14, lower bound of A to D is 16, lower bound of A to E is 19. So we have to find the minimal value among these values. So minimal among these values is 14, that is considered the node and that node is expanded. For two-way communication is ABC, ABD, ABE. Because we are going to consider A as a starting node, A to B one point communication, B to C another point. Here two-step communication. A to B is one point communication, B to D is another point communication. This is two-step communication. A to B is one point and B to E is another point. So two-step communication. Here we have seen A to B, A to C, A to D and A to E. That is single point of communication. So now we can see the calculation for ABC. A equal to, here connection is from A to B and B to C. So connections from A to B should be considered and A to should be considered. A to B and B to C should be considered. That is mandatory for placing in our problem. A equal to, already we have A to B and next minimal value is considered. A to B is taken, the next minimal directly connected, this will be considered. A is connected with E, C, D and D. A to B is already placed because A and B. A to B தான் இங்க கனெக்ஷன் இருக்கிறதுனா A to B ஏற்கனவே place பண்ணியாச்சு. Plus minimal value is A to C 1. Next B. B is the node. B is connected with A, C and D. But B is இங்க வந்து strong connection of B to C is there. B is connected to C. So B is connected to C. B is connected to C should be taken whether it is minimal value or maximum value because it is strong connection is given here. அதனால B to C is taken here. B to A. B to A is taken because the strong connection of A to B is there. As there is a strong connection of A to B is there, there will be a strong connection of B to A also. So we are going to take B to A and B to C. So 3 plus 6 equal to 9. C. C equal to minimal value is going to be checked. C to A, C to B, C to E. The minimal value is C to A has the minimal value of 1, C to E has a minimal value of 2. C to A is taken and C to E is not considered because we have a strong connection between C to B. So that C to B strong connection is placed, the minimal value C to E is not considered. So 1 plus 6 equal to 7. Next D. D, the direct connections are D to B, D to A, D to C and D to E. So minimal among this is considered. D to E is the minimal 3, D to C is minimal 4. So D to E plus D to C, 3 plus 4 equal to 7 is considered. E node is taken, the minimal value is going to be placed. It is connected to E is connected to A, E is connected to B, E is connected to C, E is connected to D. So minimal among this is 8, 2, 3, 9. Minimal is 2 and 3. So D, E to C, E to D is considered. 2 plus 3 equal to 5 is considered. 4 plus 9 plus 7 plus 7 plus 5 equal to 32 by 2 equal to 16 is considered as the lower bound value. Now when we are going to check with the lower bound values, here ABC we get the lower bound value is 16, ABD we have the lower bound is 16, ABE we get the lower bound is 19. As per the concept of a problem, the minimal lower bound should be considered. The minimal lower bound should be considered means minimal value is 16 in the ABD and for ABC we have 16. So both are minimal value. So both are extended. Here when we are going to extend as we get both the minimal value ABC that is extended and ABD is also extended. Now we go for two-way communication. Two-way communication is when you are going to see ABC, we had ABC பார்த்தாச்சு. ABC two-way மாற்றும்போது ABCயோட காம்பினேஷன் வேறு என்ன நோடில் ஆட் பண்ண முடியும் தான் சேர்க்குறீங்க. ABC காம்பினேஷனை வேறு எந்த நோடு ஆட் பண்ணலாம். இப்போ ABCனா ABC இதோட காம்பினேஷன் எந்தெந்த நோடு ஆட் பண்ணலாம். directly connected nodes, so C should be added. Then A, B, C directly connected nodes of C and B is C is already connected to B, but the concept is A, B, C. You have to find the direct connected just for C. C is directly connected to D, so that is given as A, B, C, D. C is directly connected to E, so it is given as A, B, C, E. In the next A, B, D, the direct connection of the node should be considered. A, B, D. D is directly connected to C, and D is directly connected to E. So now we can see the calculation. A, it means that A to B, B to D, D to E, there is strong connection. So we should not disturb this connection. So for A node, A to B is already a strong connection. So we place that connection A to B 3. And remaining node should be checked. A is connected to D, A is connected to C, and A is connected to E. When A is connected to C, it is the minimal value. So it is taken A to C. A to B is 3, A to C is 1. 3 plus 1 equal to 4. B is taken, B node is considered. In B node, B is connected to A, that is a strong connection that is considered. B node connection checking, we will be checking with the B node connection. B is connected to A, it is strong connection, it is considered. Next, B is connected to D, it is also a strong connection. So that is taken. We need two adjacent nodes. Both are strong connections, so we have taken both. 3 plus 7 equal to 10. Consider node C. C node is not in the strong connections, so we have to find the minimal value. C is connected to A, C is connected to B, C is connected to D, and C is connected to E. We have to find the minimal value among these values. So C is connected to A is the minimal value. A to C is given here, and C is connected to E is the minimal value that is given here. 1 plus 2 equal to 3. Next, the node connection from D should be taken. D is connected to E, D is connected to C, and D is connected to B. D to B is B. Now, we have strong connection from B to D. So even though whatever may be the value what we have, B to D should be taken because B is directly connected to D. And D2 is also strong connection, even as D is connected to E, that strong connection should be considered without considering the values. So B to D is a strong connection, D2 is a strong connection, the values are fixed. B to D we have 7 and D to E we have 3. 7 plus 3 equal to 10. Consider E node. E is also strongly connected. We have to find the direct connection of the nodes E to C and C to E to D, E to A, E to B. Here we have to see the strong connections. Strong connections are E is with the D. So that strong connection is considered. The next minimal value is considered. C to E has minimal value that is taken. So 2 plus 3 equal to 5. Lower bound equal to 4 plus 10 plus 3 plus 10 plus 5 by 2. Add output is 32. 32 by 5 is 16. 32 by 2 is 16. Now we have, after calculating all the lower, same procedure is followed and the remaining in a lower bound is calculated. In this 24, 24, 24, 19 and 24, these are all these values. We are going to find the here we are going to see the final value. Here A, B, D, A, B, C, D, E, A. Here A, B, C, D, E, A. We have completed A, B, C, E, D, A. A, B, D, C, E, A. A, B, D, E, C, A. All the values are calculated and lower bound is 24, 19, 24 and 16. 16 is considered the optimal tool. So we can give explanation what is first two, better two, inferior two, and optimal two. Now A is connected to B, B is connected to C, C is connected to D, D is connected to E, and E is connected to A. Now as per the concept of the traveling salesman problem, all the nodes should be visited, no node should be revisited, and the starting node should be the ending node. Here all this satisfied, so this is considers the first two. Here A, B, C, E, D, A. All the nodes are visited, no node is revisited, the starting node is the ending node. So this is the better tool. Next one is A, B, D, C, E, A. All the nodes are visited, no node is revisited, the starting node is the ending node. Next A, B, D, E, C,